This time we have a kind of a different kind of function. We are going to analyze using calculus y equals x times the square root of 2 minus x squared. First off, we see that the domain is the interval from negative square root of 2 to the square root of 2. And let's see. Our x-intercepts are going to be 0, 0, and then the endpoints. Plus or minus square root of 2, 0. And of course, 0, 0 is also the y-intercept. We don't have any asymptotes because this isn't a fraction, essentially. So let's go on to the derivative. Y prime. Go ahead and find y prime. Come back when you are done. Using the product rule and chain rule, I get that y prime is 2 times the quantity of 1 minus x squared over the square root of 2 minus x squared. So we have critical numbers. X equals plus or minus 1. X equals plus or minus the square root of 2. To make sure we're real clear on this, the reason x equals plus or minus 1 are critical numbers is because that zeroes out the numerator, and so we're going to have horizontal tangents there. That's pretty straightforward. Plus or minus square root of 2 zero out the denominator of y prime, which means that those numbers are not in the domain of y prime. However, they are in the domain of y. That makes them critical numbers. When we consider intervals of increasing and decreasing, we're only going to consider numbers in the domain, so from negative square root of 2 to square root of 2. And then our numbers of interest are negative 1 and 1. And because the square root of 2 is about 1.414, looks to me like numbers like negative 1.2, 0, and 1.2 will do what we need. And using those numbers, we're going to find that the derivative is negative between negative square root of 2 and negative 1, positive between negative 1 and 1, and negative between 1 and square root of 2. And so we can mark those over here in kind of our list of stuff that we're gathering. We could say something about local min and local max, but I'd rather go to the second derivative now. And as a matter of fact, what I'd like you to do is take y prime and differentiate it, simplify it to get the second derivative, come back, and we'll talk about concavity. I've got the work that I did here, and I ended up with y double prime is equal to 2x times the quantity of x squared minus 3 divided by 2 minus x squared to the 3/2 power. Now, when we want to analyze the signs of y double prime, again, we got to think about the domain of our function. X equals 0 is clearly a 0 for y double prime, right? X is a factor in the numerator. But negative square root of 3 and square root of 3 are outside of the domain of our function, and so we don't care about them. It's pretty straightforward to see that if x is negative, then, well, I guess it's not quite so straightforward. This is a negative term, 2x, but then if x is between 0 and negative square root of 2, then this factor is going to be negative. So our second derivative is positive between negative square root of 2 and 0 and negative between 0 and square root of 2. Therefore, our graph is concave up on the interval from negative square root of 2 to 0 and concave down on the interval from 0 to the square root of 2. Now remember, our critical numbers were plus and minus 1. And according to where they are in terms of concavity, we know that we have a local max at x equals negative 1 and a local min at x equals 1. You can see I decided to use the second derivative test there. Also, concavity switches when x is equal to 0, so we have an inflection point at x equals 0. Now we can put that stuff into, say, an xy table. I'll do it down here, x, and then y is equal to x times the square root of 2 minus x squared. And our numbers are just negative 1, 0, and 1. 0 maps to 0. So we can talk about our inflection point. Inflection point is 0, 0. When x is negative 1, y is negative 1. When x is 1, y is 1. So we have a local min that is negative 1 because of that number. And we have a local max, which is 1 because of that number. Okay. Now I have a bunch of information in front of you, namely all this stuff over here. And I'd like to use this information about the domain, intercepts, intervals of increasing and decreasing, concavity, the inflection point, and local extrema to, you guessed it, sketch the graph of the function. Come back when you're done. Here's my grid. I've got points at negative 1, negative 1, 1, 1. Got one here at 0, 0 because we knew those. And then I've got, I'll mark negative square root of 2 and square root of 2 on the x-axis. And we're going to connect these with a nice smooth curve. Now what's happening at the endpoints? Remember, we got square root of 2 and square root of 2 as values for which y prime was not defined. Therefore, the tangent line at negative square root of 2 and square root of 2 should be vertical. For everything else, we're concave up and then concave down, and I hope your graph looks like this.